In the introductory video, I mentioned that the vast majority of programming doesn't really require that much mathematical knowledge beyond basic algebra. However, there is one key mathematical concept in programming which you may or may not have been well exposed to in your math education, and that is the subject of number systems. Now, of course, in a sense, you already understand number systems because you already use one. You use what is called decimal in everyday life. It is a positional notation system, and it uses base 10, by which we mean it uses 10 symbols. Here are those 10 symbols, which I'm sure you're familiar with. And not only do we have a fixed set of symbols with which to express quantities, but those symbols also have an established order, as shown here. What this means is that if we are at, say, 2, and we want to express one higher, then we go to 3, and then we go to 4, and then 5, and then 6. We don't go from 2 to 6 or 2 to 0 or some such. We always move forward in this order. The only problem then is what happens when you get to 9? Well, we loop back around. There's an important rule that goes with this, and that is that when a digit cycles from 9 back to 0, then this means the digit to its left must cycle also by 1. So say the quantity 39, when we express the quantity 1 higher than 39, the 9 cycles back to 0, and then the digit to its left, this 3, cycles to 4. So 1 higher than 39 is 40. You may be wondering now, well, what if there isn't any digit to the left of a 9, and you want to express 1 higher? Well, the answer is that there's always a digit to the left of a 9. In fact, there's an infinite number of them. There's an infinite number of zeros. So say if you want to express 1 higher than the quantity 9, this 9 cycles from 9 to 0, and then this 0 cycles from 0 to 1. So we get the quantity 1, 0. Another thing to note is that when you have a whole bunch of 9s in the rightmost digit places of a number, then when you express 1 higher than this, you get a cascading effect. So 1 higher than 76,999, what we do is this cycles from 9 to 0, so then this cycles from 9 to 0, so then this cycles from 9 to 0, and then this cycles from 6 to 7. So 76999 becomes 77000. So positional notation systems like, say, decimal, have a few nice things about them. First, you don't have to come up with a unique symbol for every single quantity you want to express. That would be pretty inconvenient. Second, you can express as large a quantity as you want. You just have to use enough digit places. Because of these two virtues, it's easier to do math in a positional notation system than, say, in a system like Greek or Roman, which are additive systems.